In algebra, we do something called linear programming, which is basically using feasible regions and what we call constraint equations to help us make decisions. So here's a pretty simple example. A company makes travel pants and shorts. Now, before I get going too far, let me just say we've got two variables. We've got P for pants, and we've got S for shorts. The company can make at most 400 travel pants. So the amount of pants has to be less than or equal to 400. Let me write that equation. And at most 600 travel shorts. So shorts are going to be less than or equal to 600. Now, before I move on to reading the rest of this, whenever you're wondering about the inequality, I would always just kind of stop and say to myself, okay, it says I can make at most 400. Can I make more than 400? Can I make less than 400? And of course, the answer is I can't make more than 400. They said at most, and that's how I always choose which way the inequality goes, is I just stop and ask myself, can I make more? Can I make less? Which of those is true? Okay. If they chose to make some of each, the material present can produce at most 480 items. Okay, this is the hardest one to write because P stands for number of pants, S stands for number of shorts. So if we say, well, the pants plus the shorts is going to be less than or equal to 480. Okay? I want to graph these equations. First off, let me just say these equations are what are called constraints. Constraints means like a limit, right? If we're under some constraint, we have some kind of thing that limits us. And that's what these are. They tell us we can't make more of this, we can't make more than this. So they put a limit on how many things we can make. All right, the first one, you'll notice I just made my graph here. We've got shorts, we've got pants. I'm going to start with pants less than or equal to 400. Now, this, because there's just the one variable, it's just 400. I'm going to go to 400, and it's actually just going to be a vertical line. So let me graph that. And I said less than, so let me kind of shade the part that's less than 400. I like to always shade these like one at a time. So right now, you might be thinking, well, do I need to shade all the way up like this? Because, we have something that limits our shorts too. We will get to that. Okay, it'll take care of that. All right, next up, we've got that the shorts less than 600. So we come to the shorts. Here's 600 right there, and I'm going to draw a line at 600. And now, since the constraint is less than, I'm going to say, okay, well, here's the part that's less than 600. And again, I could go the whole way and say, okay, it's all of this too. But at this point, we're going to be focused on this rectangle where both of them are highlighted. So I'm just going to get rid of the rest of this, okay? I know that on your own paper, you probably won't be able to do that, but I can do that. I can just say, no, we don't need to worry about any of this stuff. We're talking about this box. This is the feasible region at this point. And finally, the pants plus the shorts has to be less than 480. I'm going to use the intercept method here. I'm going to say, all right, if I made no pants at all, I could, according to this constraint, made 480 shorts. So I'm going to put a point here at 480 shorts right in here. Okay. And if I made no shorts at all, I'd make 480 pants, which again, you might say, well, you said we can't do that. That's true. Well, let's get this graph in here, and then we'll shade. So less than, that would be below that line. So let me kind of combine everything at once. This is the feasible region. This is the region I'm talking about. Okay. This is the little, I guess, trapezoid where everything is true. Now, these points that kind of make up the trapezoid We call these the vertices. And the vertices are going to help us in what we call optimization. So let me read the next part of this question. If the profits from the pants are $35 and the profits from the shorts are $26, what amounts of each item should the company produce to make the largest profit? Well, let me really quickly make a profit equation. So profits, well, we make $35. I better use a different letter here, or maybe just write profit. $35 for each pair of pants. So 35 times P tells me if I sell how many pants, how much money I make, and $26 from each pair of shorts. Now, a couple of kind of logic things I just want to talk about here, because oftentimes when students see linear programming problems like this, it becomes very overwhelming, right? We've got to read a setup and write our constraints. That's kind of difficult to do at first when you're starting out. You have to do the graphing and the shading, and that's a lot when you're just starting out. And then not only that, but now we're trying to maximize the profit. We call this optimization because sometimes you maximize something, or maybe it was a different setup and you were trying to minimize your costs. Optimization covers both of those things, max and mins. We write this equation, and now you've got to start evaluating different points and kind of thinking about it. There's a lot of logic at play here that I want to point out. Okay, that's going to make our work a little bit easier. First off, this is our region that is feasible based on our constraints. This darkly shaded region, this is all we need to think about. But let's think about it. We're trying to maximize our profit. If we want to maximize our profit, that's not going to happen by picking some random assortment of pants and shorts in here. It's going to happen when we make the most product we can. And that's going to occur along this line where we were making the most, all right? It's certainly, it's not going to happen at an interior point. It's going to happen on an edge. Not only that, it's going to happen at a vertice, okay? Now, let's go through some vertices, and let me point out you are absolutely free to type in every vertice. I can write all these down. I can say, okay, this one is 0 pants and 480 shorts. This one was 0, 0. But think about that. Why, if we're trying to maximize our profit, would we make no items? Okay, down here we have 400 pants and no shorts. Think about that. We're allowed to make 480 items. Why wouldn't we make all 480? Doesn't make any sense. And then up here, 400 pants and 80 shorts. Okay? Now, again, we are totally free, totally welcome to plug in all 4 of these points into our profit equation and just see, hey, which one's the biggest profit? But I'm going to argue that we can cross 2 of these out right away. No sense in checking 0, 0 because 0, 0 gives us no profit. And there's no sense checking this one because why, if we're allowed to make 480 items, would we not make 480 items? So let's type in these 2, okay? Profit. So in this point, we made 0 pants, so 35 times 0 plus 26 times 480. And down on this point, we made 400 pants and 80 shorts. Now, we could also just maybe think of the logic here, and I'm going to circle what the answer is. In both of these points, both of these vertices, we made 480 products. Here we made 480 of something that made us less money. Here we made the absolute maximum amount of something that made us more money, and then we filled out the other 80 items with the other. So obviously, I hope from a logic standpoint, this is the mix. We should make 400 pants, and we should make 80 shorts. You are certainly allowed to type those in, figure out what the answer is, but we don't have to, I don't think, because we can think through the logic of this. The math backs us up. And this is linear. Always begin with reading the question and writing down what the constraints are, what numbers kind of guide what we can and can't do, graph those constraints, and find the region that works for everything. Then we have some kind of optimization problem, some kind of equation that tells us what we're trying to either maximize or minimize, and we plug our vertices in. You are always free to plug all the vertices in, but I would argue a lot of times we don't have to. We can kind of use logic and let the math kind of guide us from there. If this video helped you, please like and subscribe for more math help.